Okay, Charlotte Ann. So for number 2, we have to look at this, and this is a segment addition postulate, okay, which is the part plus the part equals the whole. So we know that this, sorry, I'm not on pen. We know that this value of 19 is the whole length, right? Because we see that it corresponds up here to the whole length of that segment. So we're going to set that up, and we're going to start with 19 equals, okay? Now, when we look at these parts of it, we have this x plus 3, which goes up to here, okay? And then we also have 17, which goes here and here. So what we end up with is this section here is duplicated because it's included in the green section and in the red section, okay? So when we set these up, we're going to need to do something about that part, about this, okay? So we're going to say x minus 3 plus 17, because those are our two parts that we know, okay? And then we know that this other part, this negative 15 plus 2x, is in there twice. So let's subtract that part out one time so that it's only in there once. So then you're going to have to distribute this negative in, okay? So what you're going to have is 19 equals x minus 3 plus 17 plus 15, because this minus minus makes it a plus, and then minus 2x. Does that help clear it up some? Does that make sense? Why we have to subtract that part out? Okay. Okay, Charlotte Ann, so for 24, we have an endpoint and a midpoint. And we know our midpoint formula is, if we write it like this, maybe this will help. X of the midpoint, Y of the midpoint equals x1 plus x2 over 2, and then y1 plus y2 over 2. So what we're going to have to do is we're going to have to label what we have. We have an endpoint, which is going to be like an x1 and a y1, okay? So x1, y1. And then we actually have the midpoint, so we have this part of that formula already. So this would be xm and then ym. So now we're going to break this out, okay, into two different parts. So xm is going to equal this part, and ym is going to equal this part. So what we're going to need to do, we'll say our xm is -2, okay? And -2 equals x1 plus x2 over 2. Well, our x1 is 10. We don't know our x2, so we'll just leave that as an x and then divide by 2. So then we'll just solve for x. The way you solve is, since you're dividing by 2, you're going to multiply by 2 on both sides. And 2 times -2 is -4 equals 10 plus x, because those cancel. And then we need to subtract 10 from both sides. So that gives us -14 equals x. Now we have to find our y, or our ym. So ym is here, 0. So 0 equals y1 plus y2 over 2. So our y1 is 4. We don't know the other term, so we'll just put a y over 2. And now solve for y. So again, since we're dividing by 2, we have to multiply by 2 on both sides. 2 times 0 is 0. So that gives us 0 equals 4 plus y. And we're going to have to subtract 4 from both sides. So 0 minus 4 gives us -4 equals y. So our coordinate is our x value, which is -14, and our y value, which is -4. Does that make sense, Charlotte Ann? Okay. And you'll do that same thing for all 4 of those, for 23, 24, 25, and 26. Okay, so for number 57, Isabel, what we're looking at is an isosceles triangle, and we have to find the value of x there. So what we know about isosceles triangles is that the sides opposite, the angles that are opposite the congruent sides are also congruent. So if we look at this triangle, there's the angle that's opposite that side. Here's the angle that's opposite this side. So we know this angle and this angle are both 43 degrees. Now, they give us a measure up here for a measure of angle 2, all right? So what we can do is we say, well, we know the interior angles of a triangle add up to be 180. So we're going to say 180 equals 43 plus 43 plus 10x minus 6. And then solve for x that way. Does that make sense? Okay, and that's going to be similar to how you'll solve 58 and 60, okay? You're welcome. Okay, Charlotte Ann, so for 40, there's a couple of ways that you can look at it. One way is to think about it as the exterior angle. So we know that this angle and this angle are vertical angles. So this measure here is also going to be 25x. And then what we have out here with this 160 is that it's an exterior angle. And remember, the exterior angle equals the sum of the two non-adjacent angles, or the two angles that it doesn't touch, okay, that are inside the triangle. So what we could do is set that equal 160 equals 8x minus 5 plus 25x. Now, the other way to look at it is, let me erase this. We know that this angle over here is 160 degrees. And we can see that it's supplementary here, right? That these two angles would both add up to 180. So if this one is 160, we know that this one would be 20. Then we know all of the interior angles add up to 180. So you could also set it up like this. 180 equals 8x minus 5 plus 25x plus 20. Either way would get you to where you need to be for the answer. Does that help for 40? Okay, let me pull up 65. Okay, so 65 is from chapter 5, this stuff that we just did. Oh, a little too far. So when we look at 65, we can tell that this here, UT, is a mid-segment of the triangle because we see that it connects the two midpoints of those sides since these two sections are marked congruent. Okay. So remember the relationship between a mid-segment and the third side that it doesn't touch is that the mid-segment is 1/2 of that whole length. So if we say 2 times 2x minus 7, that would equal x plus 13. The other way to do it would be to say 1/2 times x plus 13 equals 2x minus 7. But nobody likes to do fractions. Does that help for 65? Was that okay? Go over 65 again. So what we're looking at here, Charlotte Ann, is a mid-segment. And that's the stuff that we just did in chapter 5. Okay. So we can tell that UT is a mid-segment of that triangle because it connects the midpoints of both of those sides. U is the midpoint of side ED, and T is the midpoint of side DC. And we can tell that because it divides those sides into two congruent parts. So if you remember in chapter 5, the mid-segment, the relationship between the mid-segment and the third side, or the side that it doesn't touch, is that it's 1/2 of that length. So 2 of these would equal the whole of this, okay? So if we say 2x minus 7, we would multiply that by 2, and that would give us the whole length, which is x plus 13. The other way to look at it would be to say that 1/2 of the whole length, which is x plus 13, is equal to 2x minus 7. But nobody likes to do fractions, so this is probably what I would go with. Does that make sense? That's okay. All right, Megan, number 97. Give me just a second, okay? Okay, so number 97 is transformations, okay? And you need to write the rule to describe each transformation. So since my copy is in color, it's a little bit easier to see, but let me zoom in. What you're supposed to do is look at the original, which is the black triangle here, and see what you do to shift it to where the blue triangle is. And the way that you can tell on your sheet is see how this is R prime, S prime, and T prime. That's the shifted triangle. The original one is just R, S, and T, and then the shifted one has the little tick marks added to the letters. So what you're going to do is I would start with R and say, okay, what did I do to it to get to R prime? Well, I shifted to the left 1, so that's going to be X minus 1. So I've got that here. Now let's check the second part of it. I had to go up 2 to get there to R prime, and up is your Y, so that would be Y plus 2. Does that make sense, Megan? Okay. Yeah, I know on those, on you guys' copies, it's a little bit difficult to see the prime marks, but that's what denotes the shift. You're welcome. All right, Charlotte Ann. So for parallel and perpendicular, a parallel slope, what do we know about the slope of two lines that are parallel? Yes, they have the same slope. So do you remember what part of the equation is the slope, like on number 31? Well, the slope is the number in front of the x. So for number 31, the slope is negative 1/2. So in order to have a parallel slope, or a line that's parallel, you're going to have the same slope. So if your slope of one line is negative 1/2, the slope of a parallel line is also going to be negative 1/2. Does that make sense? And then for perpendicular slope, perpendicular is the one where you have to flip it and make it negative. So looking just for example at number 31, if you needed a slope that was perpendicular to that, you would have to flip that negative 1/2 and make it 2. And then because it's a negative, you're going to change the sign. So it would be a positive 2. So if we look at number 36, to find a perpendicular slope for that, what's your slope on 36? Yeah, the perpendicular slope would be a positive 1/3 because the slope of 36 is negative 3. So the opposite reciprocal would be a positive number. And instead of 3/1, it would be 1/3. It's a good review going into the second semester because we'll need all this stuff again. I would like for us to turn it in when we get there, but we can take a little bit of time to go over questions if anyone has some. I just want to make sure that we have time to go through it during class tomorrow so that you guys know what's right, what's wrong. That way you're not studying the wrong stuff. And if you have questions while you're working through it, even though Math Lab's close to being over, you can email me too, and I can reply to you throughout the day. You're welcome, Isabel.